Okay, so in this lesson, we're going to take all of the formulas that we've learned regarding trigonometry, and we're going to talk about how you decide when to use what. So the first page here, I've just got all the information we can do with right triangles, Sohcahtoa. So if you have an angle, theta, then of course you have the opposite across, you have the hypotenuse across in the right angle, and you have the adjacent, and we have sine, cosine, and tan. So anytime you run into a right triangle, you want to use this stuff. We also know Pythagorean Theorem. If the hypotenuse is called C, and the opposite and the adjacent are A and B, it doesn't matter which one's A or which one's B, then C squared equals A squared plus B squared. If we don't have a right triangle, we then label the triangle like this. There's no hypotenuse now, okay? So we can't talk about a hypotenuse. Instead, we talk about side A being across from angle A, side B being across from angle B, side C being across from angle C, and so on. And then we have the cosine law and the sine law, and then the cosine law rearranged to solve for an angle if you have all three sides. I know this is a lot at once, but remember these two formulas are really the same. All you've done is flipped what's on top of the fraction with what's on the bottom. And these three formulas are also the same because A, B, and C, there's nothing special about those sides. So I could label a triangle however I want. But if it helps you to see the formulas in all three forms, there they are. Same with these three formulas, they're all really the same. You want to find the angle A, then you need this side across from A right here and the other two sides here and here. Same with these two formulas. So suppose that you are looking at a trig problem and you're trying to solve. How do you decide what to do? Well, the first question you should ask yourself is, do you have a right triangle? If you have a right triangle, then use Sohcahtoa or the Pythagorean theorem. Do not try the sine law or the cosine law. The sine ratio or the cosine ratio or the tan ratio are what you should be selecting. By the way, there's no such thing as the tangent law, in case you were wondering. Okay, suppose you don't have a right angle triangle. Okay, there's no right angle, so you know that you're working with a triangle like this. It's got to be one of these things. Okay, I would check and see, do I have side, angle, side in that order? Is this what I'm working with? Side, angle, side, and the angle is in between those two sides. And then I'm looking for the third side. That's the cosine law. And that's a pretty easy picture to kind of see, okay? You might have, 10 and 12 and a 30-degree angle in between. If you don't have that, do you have all three sides and you're looking for one of the angles? In which case, again, that's the cosine law rearranged, which would be like one of these formulas here. These are the formulas you use when you have side, side, side. I mean, look at it. It's all three sides are in the triangle, or in the formula, pardon me. Okay, so suppose you don't have that. None of the above here. It's not a right angle triangle. It's not side, angle, side. It's not side, side, side. It is something else. Then try the sine law, okay? Examples of that are angle, side, angle, or angle, side, side. And then the sine law. In each of these cases, like angle, side, angle, you might have the side, an angle, and another angle. The important thing is you're able to find this, you're always able to have a side and an opposite angle to work with somehow so that you can use the sine law. I mean, that's how I recommend you do it. I always say look for the cosine law first. It seems easier to figure out when to use the cosine law. And then if that doesn't work, try the sine law. You can't really go wrong in a sense. If you know how to use the formulas correctly, what'll happen is if you get to a cosine law question and you try using the sine law, you'll find you just can't get anywhere. And if you're in a sine law question and you try to go using the cosine law, you don't get anywhere. I mean, imagine you had angle, side, angle, and you tried to use the cosine law. Well, you don't have two sides. So how in the world are you going to use the cosine law when you don't even have two sides, B and C, to work with? So it's not like you can accidentally use the wrong formula and get the wrong answer. You just get stuck. If you do have three measurements, if you've tried all these and you still can't get anywhere, it must be that you don't have enough information. You need at least three pieces of information about a triangle to solve it. And one of the pieces of information can be the 90-degree angle if it's a right triangle. The only time that doesn't work is all three pieces of information are angle, angle, angle. You can never solve a triangle like that. You don't know how big it is. Okay, let's look at some examples. Okay, looking at the very first triangle here. Okay, it's not a right angle triangle. There is no right angle. So then I start asking myself, do I have side, angle, side? Oh, look at that, I do. Side, angle, side. This is a cosine law question. So d squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 25 degrees. And go from there. 15 squared plus 10 squared will be, I believe, 325. Okay. Subtract, let's see, this is going to be 300. The cosine of 25 degrees, I use my calculator to get that, and I get about 0.9063. Figure out what d squared is. I get 53.11, and then finally take the square root of that to get your answer, and it's about 7.3 feet. And of course, always make sure that that answer makes sense. 7.3 feet seems reasonable. 25 degrees is a small angle. The smallest side is across here. Okay, let's try the next one. Taking a look at the next triangle, I see, hey, there's that right angle there. That means that I'm either using Pythagorean Theorem, which I'm not here because I don't have two sides, or Sohcahtoa. So I want to go with Sohcahtoa here. So now it's just a matter of remembering how do we use Sohcahtoa, sine, cosine, and tan ratios. Well, I look at 42 degrees. Here's the hypotenuse, the opposite side, and the adjacent side. Now, when you're solving for a side, you want to use the side you're looking for, which is the opposite. Okay, so we're not going to be using cosine. There's no opposite, no O in cosine. It's definitely not that one. You want to use the side you're looking for and a side you know, so you only have one unknown. So opposite and adjacent, this is tan. So the tan of 42 degrees is equal to opposite over adjacent is x over 9. Now, how do I solve this? I either put tan 42 over 1 and cross multiply, or I just realize I multiply both sides by 9. The answer is going to be 9 times tan 42. Use my calculator, see what you get there. Gives you about 8.1 centimeters. So there you go. There's an example where you do have the right angle triangle. Okay, the next one. Okay, in the next one, I clearly do not have a right angle triangle. So I move on to the next part of the checklist here, which is, do I have side, angle, side? Looking for a third side. Side, no, this is like angle, side, angle. It's not side, side, side. This must be a sine law question, number 5. So let's try that. Okay, so we're looking for A. And sure enough, we have the angle opposite A. So A over sine 59 is equal to, okay, I've got 16. I need angle B here. B is going to be 180 minus 42 minus 59. Sorry about that. Minus 59. And that gives us B is about 79 degrees. Okay, so now I know B. I needed B because I have to work with this 16 right here. I don't have any other choice. So equals 16 over sine 79. Okay, multiply both sides by sine 59. Kind of the same thing as cross multiplying. 16 times sine 59 degrees divided by sine 79 is going to give you your answer. Use your calculator for that again, and you should get very close to 14 centimeters. Okay, and from there you can go ahead and solve the rest of the triangle if you wanted to. By the way, once I have suppose I did want to solve the rest of the triangle, I know this is 14. Now I can use a lot of different things to find this side. I could use sine law again. I could use cosine law because I have side, angle, side. Once you have more information about a triangle, you have more choices about what formula to use. But here I'm just going to stop there. Okay, let's look at the next one. Okay, so we don't have a right triangle here. So we're not going to use Sohcahtoa. Do we have side, angle, side? No, we don't. And we don't have all three sides. So this has got to be a sine law question. Now, notice I've got 4 feet 6 inches. 6 inches is half a foot. So this is really 4 6.5 feet, because it's easier to work with decimals when we actually go to do the math. 6 foot 1 inch. Well, how many feet is 1 inch? It's one. There are 12 inches in a foot. So take 1 divided by 12, and that gives you it as a decimal. It's about 6.08 feet. So it may be a bit of a bad example. Like 4 feet 6 inches does not mean 4.6 feet. 6 foot 1 inches doesn't necessarily mean 6.1 feet, but it is very close to 6.1 feet. It would round to that. Okay, so like I said, we've got a sine law question. We want to find side R, but we're having a bit of trouble here because we're not going to be able to get it right away. We don't know this angle and we can't figure it out. So what angle can we figure out? Well, I mean, we've clearly got to use 6.0. If we're going to find an angle, we've got 6.08 over the sine of 73, because this is opposite that. Okay, and then I can use the 4.5 to find this angle right here. I'll just give it a name. I'll call it theta. Sine theta, all divided by 4.5. Okay, so there we go. I can solve for theta. I don't have a choice just because, so this, although this is a sine law question, you're still not able to solve for the side you want right away, the side R there. We're actually going to have to wait until the end to find that. Okay, multiply both sides by 4.5. And you get 4.5 times sine 73 divided by 6.08. Okay, now I'm going to figure out what all that is. So that gives me sine theta. Okay, 4.5 times sine 73, and then divide that by 6.08. And I get about 0.708 is about what I get there. Okay, now I'm not going to show you the work here, but you know that you do the inverse sine now to figure out what that angle is. Okay, so do second function sine on your calculator likely, and you should get about very, very close to 45 degrees when you do that. So that angle is really close to 45. Okay, so if theta is 45 degrees, there's another angle up here, and this angle right here is going to have to add to 180 with these. So we know that it is 180 minus 73 minus 45, which is equal to 62 degrees. And then finally, we are ready to answer this question. We're finally ready to find R because we have the angle across from R. So R divided by the sine of 62 is equal to, I'll use the, what will I use next? I'll use the 6.08 and the sine 73. I could use either one, it doesn't matter. From there, I get that R is going to be 6.08 times sine 62 divided by sine 73 degrees. I'm kind of running out of room here. Use your calculator and get that one. That gives me about, if I use my calculator here, I get about 5.6 feet. That's actually 5.6 feet. I'll leave it like that for now. That's not 5 feet 6 inches. You could multiply 0.6 by 12 to get the inches, but I'm not going to worry about that yet. We're going to get into that kind of stuff later on. So this is about as tough, in some ways, as tough as they get. You got to use the sine law twice to actually get your answer and subtract from 180 to find that angle. Okay, one last example, solving this triangle, finding all the sides, all the angles. Let's label it. Let's give it some names. I'm going to call this A, B, and C. They gave us what is angle C, so we need to find little c still. And this would be little a right here. And then obviously little b right here. Okay, it's not a right angle triangle. It's close, 87, but it's not. There's no side angle side. There's no side, side, side. This is another sine law question. We have to get started with the sine law. After that, we can do whatever we want. Now, I should say that the first thing we can do is find angle B since we have two other angles. B is going to be 180 minus 42 minus 87. So let's see what we get there. 51 degrees for B. Okay, now like I said, we need to use the sine law. I can add that to the picture if that helps. The sine, let's solve for side C. So C over sine 87 will equal B over sine B, which in this case is 18 over sine 51. If you're still having trouble with that sine law, just remember you're looking for the across pattern, okay, with the side. So that's why those two are matched up, and C is the one I don't know. Multiply both sides by sine 87, you get 18 sine 87 divided by sine 51. Use your calculator to solve for C there. And you should get 23.1. There's no units here, but there you go. So there's another answer. We've got two pieces of information. There's still a third piece of information missing, and that is side A. And now we have a choice for side A. You can use the sine law, because you can say A over sine 42 equals one of these two pairs that we already know. Or you can say, hey, I've got side, angle, side now. I could find the cosine law to solve for A. So there are a number of different ways once you're down to that last measurement. Personally, I find the sine law is the quickest, so I'm going to choose to use that. So A over the sine of the angle at the top, which is of course 42 degrees, is equal to, let's see, let's go with B and 18 over sine 51. Now, that's not the only possible formula you could come up with. Instead of 18 over sine 51, you could have done 23.1 over sine 87. That would give you the exact same answer. Or you could have said a squared equals 18 squared plus 23.1 squared minus 2 times 18 times 23.1 times the cosine of 42. That's just using the cosine law. Give you the same answer as well. Okay, just continuing with this. That gives me that a is equal to 18 sine 42 all divided by sine 51. That's going to be the last answer that we need in this question. 15.5, whatever the units are. And there we go. Okay, really important set of homework questions right here, okay? Gotta make sure that we can do this, because now, unlike the other lessons, you're not necessarily right away going to know what to use. So make sure that you give those a try. Okay, thanks.